Hi guys, this is AS Chemistry, Organic Chemistry, and we are looking at halogenoalkanes. Question 1. In each section of this question, the structural formula of an organic compound is shown. For each compound, answer the questions about it. So the first compound is CH3, CH2, CHBr, and CH3. And they've asked, name this compound. So Br is attached to the second carbon atom in a chain of 4 carbon atoms. So the name of this compound is 2-bromobutane. This compound shows stereoisomerism. Draw the two stereoisomers in the conventional way. So we have a chiral carbon atom present in 2-bromobutane, which is the carbon atom to which the bromine atom is attached, because that carbon atom has 4 different groups attached to it. One of them being the hydrogen atom, the other being the bromine atom. The third group present is the CH3 group, and the fourth group present is the CH2 CH3 group. So these are the 4 groups that will be present in the two optical isomers that will be made. So placing hydrogen on one side and bromine on the opposite side of hydrogen would be the same groups on both the isomers, with CH3 present on the right side of the isomer on the left. CH3 would be present on the left side on the isomer on the right. And in a similar way, in the isomer on the left, we would have CH2 and CH3 group placed on the left, and on the isomer on the right, the CH2 CH3 group will be placed on the right. And in this way, we have drawn two optical isomers of 2-bromobutane. Give the structures of three other structural isomers of C4H9Br. So one of these is 2-bromobutane. So we can have 1-bromobutane, in which we would start off with a CH3 group followed by 3 CH2 groups, which is finally attached to a bromine atom. So this would be known as 1-bromobutane. Then we can have another isomer in which there is a substitute group present on one of the carbon atoms in the chain. So the chain becomes 3 carbon long because one of the carbon atoms is now a substitute group. So the name of this particular compound is 2, or rather we start with bromo because B comes before M. So it will be 1-bromo, 2-methyl, and we've got 3 carbon atoms in the chain, so propane, and a third structural isomer in which we would have Br attached to a carbon atom to which there are 3 CH3 groups attached. This would be a tertiary halide. So the name of this tertiary halide would be 2-bromo, 2-methyl, and 3 carbon parent compound, so propane. And in this way, we have drawn 3 different structural isomers having the molecular formula C4H9Br. The first and the second isomers are primary halides, and the third one is a tertiary halide, whereas 2-bromobutane that was mentioned earlier is a secondary halide. Okay, so another compound is given and they want us to name this compound. So we need to draw this compound to understand what to name it. So we start off with CH3 CH2 attached to a carbon to which there is another CH2 and a CH3 attached, and another CH2 and a CH3 attached. So there are 3 CH2 CH3s attached, and a bromine is attached on the fourth bonding position. So the name of this compound would be 1, 2, 3, 4, 5. There are 5 carbon atoms in the parent chain, So, and the substitute groups are bromo and methyl. So the name would be 3-bromo, 3-ethyl, and a 5-carbon parent compound would be called pentane. This compound reacts with aqueous OH negative ions. Complete the mechanism for this reaction, including all necessary curly arrows, charges, partial charges, and lone pairs. So, since this is a tertiary halogenoalkane, it will undergo the SN1 nucleophilic substitution reaction mechanism. So, that would require the C-Br bond to have a partial negative and a partial positive charge present on it, and it would require breaking of the C-Br bond through heterolytic fission, resulting in the formation of a carbocation. And this carbocation would be CH3, CH2 attached to the carbon atom, to which the Br atom was attached. And since the Br atom has been removed, there would be a positive charge on this carbon atom, making it a carbocation. So this is the carbocation that is produced. And we also have the formation of a Br negative ion having a lone pair of electron. This lone pair of electron gets attracted towards the positive charge of the carbocation. Result, in fact, this Br was broken off. So it will not be the Br that will be attacking the carbocation, because that is the one that has been removed. It will be the OH negative ion, because the OH negative ion is added to the tertiary halide. So instead of the Br negative ion, because Br negative ion was the one that was removed from the halogenoalkane, we would have the OH negative ion, because of which this reaction started, and the oxygen atom having the lone pair of electron which gets attracted towards the carbocation, and when OH negative ion adds on to the carbocation, we have formation of a tertiary alcohol. The OH group attaches to the same carbon atom to which the Br was attached to originally in the reactant, and in this way, through SN1 nucleophilic substitution reaction mechanism, we have formation of a tertiary alcohol from a tertiary halide. What type of mechanism occurs in two? It is an SN1 reaction mechanism, which is known as nucleophilic substitution. CH3, CH2, CH2, CHBr, and CH3. So this is 2-bromo pentane. Give the reagent and condition necessary for the conversion of this compound into a mixture of alkenes. So this would require removal of a bromine atom from the carbon that has bromine on it, and a hydrogen atom from either of its adjacent carbon atoms. So this is an elimination reaction, which is also known as dehydrohalogenation. And the reagents required for dehydrohalogenation are NaOH plus ethanol, and plus the conditions needed are heat under reflux. Give the name of the mechanism for conversion in one. So the name of the mechanism is an elimination reaction, and the type of reaction is known as dehydrohalogenation. Draw the skeletal formula of the three alkenes produced by the conversion in one. So we've got 5 carbon atoms, and if the hydrogen is removed from the terminal carbon atom, we would have a double bond present between the first and the second carbon atom. So we would have a double bond present here. So this is the alkene that would be produced if hydrogen is removed from the first carbon atom. But if hydrogen is removed from the third carbon atom, we end up with an alkene in which we have a double bond between the second and the third carbon atom. So the structure of that alkene would be this way if it shows the cis isomerism or cis conformation, and if it would show the trans conformation or trans isomerism, the structure would be this way. So the name of these compounds would be, in the case of the first one, it would be pent 1 ene. In the case of the second one, it would be cis pent 2 ene, and in the case of third one, it would be trans pent 2 ene. And these are the three alkenes that will form when 2-bromopentane would undergo an elimination reaction mechanism. Question 2. Halogenoalkanes have been widely used as aerosol propellants, refrigerants, and solvents for many years. Fluoroethane, CH3CH2F, has been used as a refrigerant. It may be made by reacting ethene with hydrogen fluoride. Another halogenoalkane which was used as a refrigerant and also as an aerosol propellant is difluoroethane, CCl2F2. State two reasons why compounds such as CH3CH2F and CCl2F2 have been used as aerosol propellants and refrigerants. So these compounds are inert, they are volatile, they are non-toxic, they are non-flammable, and they are easily liquefied. And because of any of these reasons, they are used as aerosol propellants and refrigerants. CCl2F2 is one of many chlorofluorocarbon compounds responsible for damage to ozone layer in the stratosphere. By using relevant data from the data booklet, and your answer to A suggests why CCl2F2 is responsible for damage to ozone layer in the stratosphere, whereas CH3CH2F is not. So the CCl bond present is the weakest compared to the CH and CF bonds having a bond energy of positive 340 kilojoules per mole. In the stratosphere, UV light from the sun makes the CCl bond undergo homolytic fission, producing chloride free radicals. These attack ozone molecules and convert them into oxygen molecules, and in this way they contribute to depletion of the ozone layer. Both CH3, CH2F and CCl2F2 are greenhouse gases. The enhanced greenhouse effect is of great concern to the international community. What is meant by the term enhanced greenhouse effect? It is the trapping of heat from the sun in the atmosphere. So this is the heat that the earth reflects back. So that heat energy is trapped because of the greenhouse gases. So it is the trapping of the heat from the sun in the atmosphere, resulting, or we can write it is a trapping of the reflected heat, because it is a heat that is being reflected by the earth, which is trapped. So reflected heat from the sun in the atmosphere, resulting in an increase in temperature, contributing to global warming. Water vapor is the most abundant greenhouse gas. What is the second most abundant greenhouse gas? It has to be carbon dioxide. Question 3. Chloropropanol such as 1,3-dichloropropane-2-ol or 1,3-DCP are present in some foods. What will be produced when 1,3-DCP is reacted separately with the following reagents under suitable conditions? In each case, give the structural formula. Concentrated sulfuric acid. So, concentrated sulfuric acid would result in dehydration taking place. So, the OH group from the central carbon will be removed along with the hydrogen atom from either of the terminal carbon atoms, resulting in introduction of a double bond in the structure of 1,3-DCP. So, the product would be Cl bonded to carbon to which a hydrogen atom is attached, double bonded to the carbon atom with the OH that was present on it, and then it forms a bond with CH2Cl. So if we are to name this compound, it would be containing three carbon atoms. So the name would be 1, 3 dichloro, and it's a three carbon alkene, so prop 1 ene. When 1,3-DCP reacts with an excess of chlorine, it will undergo a nucleophilic substitution reaction in which the chlorine atoms would be replaced by the NH2 groups from ammonia. So the structure that would form would not have anything happen to the OH group, so the OH group will remain. So we will have CH2, CHOH, and CH2 remaining as it is. And in place of Cl, we would have the presence of two NH2 groups, resulting in the formation of a diamine. So the name of this compound would be 1, 2, 3, three carbon containing diamine. So it will be called 1, 3 diamino, and it's a three carbon alcohol. So propane 2 all. Describe as fully as you can what type of a reaction occurs with ammonia. So the type of reaction that occurs with ammonia is known as nucleophilic substitution. Question 4. Chloroethane undergoes a series of reactions as shown in the diagram below. So chloroethane in reaction 1 results in the formation of an alkene. So this is an elimination reaction which would require NaOH plus ethanol and plus heat under reflux so that the elimination reaction occurs and dehydrohalogenation of chloroethane results in the formation of ethene. In the reaction on the left, we have chloroethane reacting with NaCN. So this would also require ethanol and heat under reflux to form product Q. So product Q would have the chlorine atom being substituted by the CN group. So this is what product Q should be. And as for the reaction with OH negative ion, the requirement would be heat under reflux only because then the chlorine atom would be substituted by the OH group forming ethanol. So the product P would be the same as the reactant. The difference would be the chlorine atom has been replaced by the OH group. So these are the reactions shown in the diagram. Give the reagents and conditions necessary for reaction 1. So reaction 1 requires NaOH plus ethanol plus heating under reflux to bring about elimination of a hydrogen and the chlorine atom from chloroethane to form ethene. Give the skeletal formula of product P. So product P would be two carbon atoms with an OH group attached to one of the carbon atoms. So this is the skeletal formula of product P, and give the displayed formula and the name of product Q. So the displayed formula of product Q would be, if we start with CH3 group followed by a CH2 group followed by a C triple bond N. This is a nitrile that has formed. So the name of this nitrile would be 1, 2, and 3. It contains 3 carbon atoms, so it would be called propane nitrile.